Okay, let's talk about the squeeze theorem. The squeeze theorem is a really important theorem in calculus. So, if we read through it, remember with every theorem we have conditions. Hey guys, do you want a treat? Come here. Hey Mel! Come here, do you want to come say hi?
What are you doing? What are you doing?
Look there and say hi.
Hi.
That's my calculus kids. They're learning lots of hard stuff.
Yeah.
Can you go play with Daddy while I finish teaching them? Does that sound good? Okay. You want to play with Mommy's magnets?
I don't.
Do you want to sit on my lap while I teach? Okay, let's teach. So, we're learning about the squeeze theorem. Once again, whenever we learn a theorem, we talk about conditions. So I'm going to specifically point out the conditions here. We have if, then. My conditions always come after if. So my first condition is that g of x is between f of x and h of x for all x does not equal c in some interval containing c. So that's a lot of jargon. We'll do an example and explain it a little bit more right now. But here is condition number 1 for the squeeze theorem. And if limit as x goes to c of f of x equals L equals limit as x goes to c of h of x. Here's our condition number 2. Like I said, a lot of math jargon. We'll do an example. I'll show you what that all means. It's easier to see it in practice than just look at the words. Then, here's our squeeze theorem. So, we have 3 functions going on in this theorem. I have f of x, I have g of x, and I have h of x. The idea behind it is that f of x is my equation that's on the lower end. H of x is my equation that's on the upper end. And g of x is my equation that's between them. So, for example, I can look at these pictures. F of x is this lower parabola. H of x is this upper parabola. G of x would have to be between them. Have to. That's that first condition is G is always between F and H. Then, so function G is squeezed or sandwiched between those other 2 functions. He's going to vacuum in just a minute. As soon as Mommy's done. Yep. Then the other condition is that both F and H have the same limit. So if I look right here, F the lower and H the upper have the same limit right there. Then the theorem says if those things are true, if G is between F and H and their limits are the same, then G also has the same limit. So it's just telling you about the limit of the in-between functions. So let's go through a couple examples. We just have these 2. So number 3, the graph of f of x and g of x are shown right here. We want to find the limit as x goes to 0 of f of x and the limit as x goes to 0 of g of x. So limit as x goes to 0 of x cubed over 2x. Well, I can simplify this to x squared over 2, which when I plug 0 in, I get 0 divided by 2, which is 0. I can do the same thing for the limit of x goes to 0 of g of x.
You want this one?
You are welcome to play with that, baby. Yes. Once again, my x's cancel. Oh, thank you. And I get negative x squared over 2. I plug in my limit, which is 0. And I get 0 over 2, which is 0.
This is Mama.
That is Mama. Good job. So, my limits are both going to be 0. the limits of
Is
f of
he a
x and g
thief,
of x.
Mama?
Yes, baby, I need you to be quiet or you're going to have to go see Daddy, okay? So the limit of f of x and g of x are the same. Now I have a third function right here, k of x. It is sandwiched between my two others. Now because k of x, condition number 1, k of x is between or sandwiched between my other two functions. Yes, that is true. K is sandwiched between those. So now I have condition number 2, and that is the limit of my functions are the same. That is also true. So the two conditions of the theorem are satisfied, so we can do the then. The limit as x goes to 0 of the new function k of x is also 0. That's all the theorem says. The limit of the squeezed function will be the same as the limit of the two other functions because they've been squeezed together. That's the squeeze theorem. We have one more video where we're going to talk about composition. We'll see if we can find something for Melanie to do.